Welcome everyone. Thank you so much for being here for another training session from the Network of Resources webinar series. So if you're joining us for the very first time, a quick reminder, this is a training initiative that we initiated in the framework of the Network of Resources ESA initiative, where we want to promote the use of cloud resources and platforms and services for Earth observation data exploitation. So every week, on Wednesday, 1 p.m., we present a platform. We dive deeper into the functionalities and capabilities it offers. And so today we're happy to have once again the Forestry Thematic Exploitation Platform, or FTEP, operated by VTT, that serves actually many users of the forestry sector. We had a few months ago already an introductory session as an introduction to the platform, where you presented us, Rene, Yuka, Lori, the different functionalities of the platform. Remember the data catalog, processing services, accessing the platform via API, service development, and also sharing and publishing processing services. Maybe I will just put the link here for the participants if you want to catch up with this session. You will find the recording on YouTube. Put it here just as a reminder. And yes, so today we're happy to have you again, but we will have a deep dive into two brand new tools that are onboarded on VTT. So the first one is Spectral Recovery, which is an open source fair software package for vegetation recovery analysis in forested ecosystems, developed by University of British Columbia and Hatfield Consultants, and integrated in the platform in Forestry TEP by VTT as a service. And the second one is Send-to-Like for harmonization of surface reflecting data products, developed by ESA and also integrated in the platform as a pay-per-use platform service on Forestry TEP. So just a reminder, please write to us your questions in the chat. We will take them as the presentation progresses, and also at the end we have a dedicated Q&A session. And now I hand it over to you, Rami, for a presentation of the tools in the platform.
Thank you, Zeina, and welcome all on my behalf as well. So we have received the introduction by ESA, and we will progress in this order with this rough schedule. First, a brief round of introductions. My name is Rene Tergujev. I'm the coordinator of the Forestry Tech platform and otherwise a senior scientist in the remote sensing team at VTT, working in project manager role as well. And then Jukka and Lauri, please introduce yourselves as well.
Yes, good afternoon everybody. My name is Jukka Miettinen and I have a forestry or forest monitoring background. So I'm in this context of Forestry TEP, I'm mainly working on the application side.
And I'm Lauri Seitsonen, senior scientist at the remote sensing team. And I have more technical role as I work as the technical administrator and lead developer of the FTEP platform.
Right, thank you. So I will give up first a brief overview of the platform, and then we will dive into these two specific tools. VTT is a big research organization in Finland, and our role is to combine businesses, companies with science and technology to solve the world's biggest challenges. And our own small corner of VTT is the remote sensing team, where we three all work. We do optical multispectral, hyperspectral, and SAR data analysis, combining them in the data fusion as well, and many other aspects as listed here. Elsewhere at VTT, hyperspectral sensor development is going on, and we, of course, work together with them in specific occasions as well. About the Forestry platform, it is an online solution for various kinds of forest analyses based on satellite data. We operate it and offer it on subscription basis, and we work with third parties to grow the set of services. The list of key platform features on the right: access to satellite data sources. We are hosted in an environment which has daily updating catalog of the satellites in the Copernicus program. Users can also upload their own data to support their analysis. The computing and storage infra is provided online. Also a set of processing services. Two examples, new examples we will look at today. And some interactive tools such as QGIS, which I think will also feature today. The key tool for third parties to bring their own services to the platform is the service development environment, and we will be happy to introduce that more closely in other occasions as well. Sharing features enable collaboration on the platform, so private services can be shared to colleagues or other users, and particular data sets and processing jobs can be shared as well. Then apart from the user interface, we offer a REST API as well as a Python client interface to access all the platform features from external systems as well. So the original development of the platform was funded by the European Space Agency. Now for some time we have been operating independently and working with third parties, as mentioned, to grow the set of services. The technical infrastructure and data infrastructure is Creodias by Cloudflare, currently also in the Copernicus data space ecosystem context. Research organizations and universities are a key user group, but also service providers in forestry and earth observation. Large forest owners and other public entities, etc., they are more typically on the end user side, but can be direct users of the platform as well. Here's a sampling of recent successful use cases of various projects on the platform. And this is one current topical message that we want to convey to you, is that we are happy to welcome new service providers with their algorithms and services on the platform as well. This was a rather concise introduction of the platform as an overview. If you go to the website ftep.com, on the offering page you can find listing of the processing services that is part that form the processing service portfolio. Spectral recovery is already mentioned here. Central-like is not yet mentioned here, but will be added soon. There's information on subscription and about how to get started on the platform. And on this registration and support page, you will also find the user manual and service developer guide and other guidance on how to access the platform. And once you have a user account, for example, a trial account, 30-day free trial account, you can access the platform here. And once you get into the platform, this is what you are faced with. This is the Explorer view, where you can define AOIs, you can change the background map, and one particularly useful new background map, it can be useful when using the Central-I, is the Sentinel-2 grid map. In the Explorer view, you can search for data with this interface for the AOI that you have selected and the time frame you have selected. and the data type and other parameters. And the search results can then be used in various services. The services that you have access are listed in this second, or via the second icon on the left. And for example, forest change S2, the simple change mapping, this kind of fields will be used to define the job configuration and then execute it. When you execute the service, you will find the jobs here, the currently executing and completed jobs, and you can review their inputs and outputs. And depending on the output type, you can view it on the map as well. But you can also use these outputs as inputs to other jobs, such as QBs, which is another service here. Okay, I won't go in more details about this Explorer interface. There's a separate interface for working with the user data. There's the developer interface where you can have a view access to some of the services, and you can create your own service via this button. So this is basically the user interface, and from here I would hand over to Jukka, who will share his own screen and start telling you about the spectral recovery tool.
Thank you. Yes, I will just first share my screen. All right. Let me know if you cannot see my screen properly. Okay, I will start with a few slides, so just the background information on the spectral recovery tool. So the algorithms behind this spectral recovery, they are nothing new. I mean, this kind of EO time series analysis for vegetation recovery monitoring has been used for a long time already, particularly in Canada, but to my understanding also to some extent in Finland, for example. And particularly this University of British Columbia has been strong in developing this spectral recovery monitoring approach, and there has been several papers on that. But what is new is that now in this recent ESA project called People Ecosystem Restoration, a tool was created that allows then easy implementation of this kind of monitoring on various platforms. This ESA People Ecosystem Restoration project was led by Hatfield consultants from Canada, and University of British Columbia was also part of the project, as were we, VTT. So we all worked together to implement this spectral recovery tool. It is available both in GitHub as Python codes as well as in the Forestry TEP platform. And you can find a lot of information about the tool and the underlying concepts in the GitHub pages actually. But the basic idea of this tool is that it allows users to perform annual monitoring or annual analysis of the recovery of an interest area. And there are two basic ways to do this. One is to use the historic recovery target. And this is the image on the left-hand side, is typically the case when you have a very clear, abrupt disturbance that the forest area has faced. So in this case, you will use the historical images, the images before the disturbance, as your reference, that this is what the area should look like. And then you have the disturbance period, and then you have the recovery period in which you do the analysis of the recovery and compare it to the reference. The other option to use this is then to use some reference area, which is not the same area as this your interest area. And this is typically the case when you have an area of interest that has been a long time, decades, for example, already in a very degraded state. And now there are efforts trying to restore this ecosystem. So in this kind of case, you cannot use the images before the recovery or restoration effort started. You cannot use those as reference, but you need to choose some other adjacent area perhaps as reference, as the target of what you would like this interest area to look like after the restoration. But in both cases, the actual recovery or restoration period monitoring is technically very similar. It's only the question of where do you compare it, or what do you compare it against. So that was the very short and simple explanation what this tool does, but there is much more information available about this tool. So you can find extensive user guide and tutorials and examples on the GitHub pages set up by the People project. And also there is a direct link to these pages from the Forestry TEP offering page where this tool is listed, which as Renne just showed. Okay, so to demonstrate this tool or how it can be used and what it can do, we created this kind of a simple demo use case, an imaginary case to us because we are not familiar with this particular area. But we found in the Czech Republic, we found an area that apparently, or my guess is that what has happened here is that there has been, this forest area has faced some calamity, perhaps bark beetle attack or something in 2015, and then perhaps followed by some salvage loggings, so that by 2017 the area looked very open. And since then, 2018 to 2023, the recovery has been very rapid. So let's assume that we are interested in analyzing this data set. So we created then a polygon of interest. So we are interested in following the recovery, particularly inside this polygon that we have created. So 2015, it was mainly forested still. 2016, we can see the damage, and the most open is 2017. And from there on, there is a clear progress of recovery. So how can we analyze this then using the tool in Forestry TEP? Here I will jump into the platform itself. So typically a user, if we are interested in this kind of analysis, for example, we would start in the Explorer interface, and typically we would start looking for available image data for our interest area. In this case, it was around here near the town of Olomouc in Czechia. And we would start by searching the satellite images, as Renne showed. I won't spend any more time on that. And when we have found the images that we want to use, then we would select the appropriate services. We might want to, depending on the image data and the type of data that we have found available, we might want to run them through some of these various pre-processing services that we have available here. Particularly this Sentinel-2 to GeoTIFF, for example, I find it very useful. For example, the example that I will now show soon, I just needed to run the Sentinel-2 images through this service and they can be inputted to the spectral recovery tool as such. But most importantly, here we will then find the spectral recovery service or tool. And when we click it, it opens it automatically in the workspace. And like Renne just said, this is the place where you input the required parameters to run this tool. I will cheat a little here and I will load an older job to make things faster. So most of the or all of the parameters required, they have, or you can see a descriptive text here, what is needed. And if this is not enough, if you do not understand from this, you can also find a link again here to the tutorials where you can find more information on the tool. But most of these parameters are quite self-explanatory. For example, this restoration area, that is our main interest area. And this needs to be a vector file. You can easily, for example, create it in your own machine and then upload it through this files interface, like I have uploaded here, in this case, the example polygon. You can just push the upload button and drag and drop it here. Very simple. You can also create it actually inside Forestry TEP using the QGIS service. Okay, then we have a reference area that is not necessarily required because we are now using the historical target. But what is the most important thing is the time series of these annual images. So each year you would have one image, and in this example that we used, all of these are Sentinel-2 level 2 images, and like I said, they have just been run through the Sentinel-2 GeoTIFF service. And actually, I think I also ran them through a QGIS service and cut a smaller interest area out of the images. But anyway, everything was done within Forestry TEP. And you input them as input images here. Then, perhaps most importantly, you need to choose the indices. This Python package or the tool itself can use hundreds of different kinds of indices, including, of course, all the most used indices. In this particular demo, I have chosen the NBR and NDVI. And then you need to choose the metrics that you are interested in. The spectral recovery package provides a few different kinds of metrics, 4 to 5 metrics, if I remember correctly, designed to monitor different aspects of the recovery of these areas. And again, you can find information on the user manual on these. But here, for example, I have chosen 2 different metrics. One is the delta NBR, which is basically the change of the normalized burn ratio index. And the normalized burn ratio index has been in many areas proven to correlate very strongly with particularly tree or wooded vegetation or tree cover. So in this case, recovery of tree cover. And RATP, on the other hand, is the evaluates the speed of the recovery towards, in this case, 80% of the reference value. So 80% of the original value in our case. Or you can define yourself the percentage, but the idea is to evaluate how close we are or already above the reference target that we have set. Next parameter is the recovery target, where we can choose whether we want to compare the individual pixels into a general level of that our interest polygon, or whether we want to compare individual pixels into the same pixel before the calamity. And my understanding is that mainly if we are interested in the recovery of that specific area, usually the polygon target is used, and so I have chosen it here as well. Then you may need to input some, if the indices that you have chosen, you may need to input some constants there, if they include such constants like the enhanced vegetation index, for example. Typically, the time step that the evaluation is done, those metrics are evaluated, it's typically 5 years. So if you have, for example, images for less than 5 years, you would need to tell here in this parameter what is the time step that you want to use for the evaluation. Target percentage is exactly the one I just mentioned, that the default is 80%, but in this case I have, for example, used 100%. Then there are some technical parameters. You can decide whether you want the output images layer by layer or stacked into one image, and you can choose the processing type. But all of these, they are shortly described here, as I mentioned. And last but certainly not least, you need to tell which are the interest years, which should be considered the reference years, when did the disturbance happen, and when did the restoration or recovery start. So these can be given here in this event years parameter. And to enable all kinds of TIFF images to be used regardless of the sensor, you need to give here the corresponding band number to the actual band information, so whether it's a blue band or green band or red band, which then the indices will need to use. So that's basically all that the user need to input, and then you can give a name label for the job and just launch it. And after that you can close the close the workspace. Okay, so then when you launch a job, it, as you may know already, it opens this data panel where you can find a lot of important information. Most of all, so you can see all the jobs that you have run and this current job that is now running here. And you can rerun it here if you want to. And you can see the status. Oops, now it's already done actually, so I was a bit late in pointing out the status of the job. And you can see all the inputs you have given. You can follow the log, how the process is going, or in the worst case, if it crashes for some reason, you can find here information, what was the error that crashed it. And most importantly then, you can see the outputs here. And in this particular job, the most important outputs or the most useful outputs are perhaps these PNG images that I will show very soon, but you also have these TIFF files if you want to open the TIFF images in some other software, for example. You can also visualize them here in the Forestry TEP. But like I said, the most interesting outputs are these PNG images, so you can easily download them and open them in your own computer. So for example, here we have now the plot trajectory. So this is the average values now for that our interest area. Remember, we chose both NDVI and normalized burn ratio, and you can see the historical reference time, then you can see the disturbance window, and you can see how the indices have developed since the disturbance. So on average, for example, here we can see that from 2017, which was the bottom, 5 to 6 years later, we have reached the NBR value has reached the pre-disturbance level, which indicates that on average the forest would be recovering or has returned in the area. If you are interested in seeing then particularly how it's distributed within the polygon, you can look at these plot metrics or pixel wise. And here perhaps I want to jump back to the slideshow. So, sorry. Yeah, so then you can compare, for example, in this case, I have now put the image that we just looked at, the metrics, and the 2023, so the last image that we have. And if you compare these images, for example, the bottom one is the recovery, the 80% recovery target, which remember we changed into 100%. You can see that within the area, in many cases, we're already above it. We have reached the target in a way, but then there are these open areas where we haven't reached the target yet. And if you compare it to this satellite image, you can see that indeed these areas look more open on the satellite image as well. But basically this is how you use the tool, and this is how you can analyze your interest areas and evaluate the recovery. I believe if there are no questions, particularly for this tool at this moment, we can probably go ahead to the next tool.
Yes, thank you, Jukka. We will have a separate section at the end, so please think about your questions for the Q&A section. Thank you. And then, Lauri, please carry on with Send to Like.
Okay, so a few words about the Send to Like service or tool. So as was mentioned, the idea is that it creates surface reflectance products that are like Sentinel-2 products from other sources, in this case mainly Landsat 8 or 9 inputs, so that we would have a compatible time series of both Sentinel-2 and Landsat 8 or 9 images that can be used in the same processing later. It produces two kinds of output product types for Landsat images. There is the level 2H and level 2F. And level 2H products are called harmonized surface reflectance products. And they are at the native resolution. In Landsat case, it will be 30 meter, and for Sentinel-2 images, it will be 10 or 20 meter resolution. And the level 2F fused surface reflectance products are converted to the Sentinel-2 resolution, which will be then 20 to 20 meter. But this requires that before the tool processes a Landsat image, it needs to have Sentinel-2 images prior to the Landsat image so that it can form the 20 or 10 meter resolution image from the native 30 meters. And theoretically, this would give us some 30% increase in the number of products that we could get when compared to the Sentinel-only situation. So we would, in optimal case, get something like 95 products per year. And as said, this is open source software developed by ESA, and they have a GitHub page from where you can download the software and look at its code and documentation. In FTEP, we have implemented two services that use Sentoo-like in two different modes. The Sentoo-like single tile service, it's a version that the user gives the Sentinel-2 tile and a time period plus some other parameters, and the service searches the Creodias archive for the given area and period to get all the relevant Sentinel-2 or Landsat 8 images. Unfortunately, the Creodias archive for Landsat 8 includes only the European archive, and it does not include any Landsat 9 images. So this is a limitation, and if necessary, then we will, if the users need more Landsat data, then we will need some ways to get the full Landsat archive to be used in this tool as well. The Sentoo-like product version is such that the user defines explicitly the images or products that will be processed. So even now it could be used so that if you upload your own Landsat 9 or 8 images, they could be processed with the Sentoo-like product service. We have configured the services to use the atmospheric correction options SMAC or Sentoo Core 3 that is able to process also the Landsat 8 images. We have the 90 meter Copernicus DEM that's available in Creodias, and we have downloaded atmospheric data from the Copernicus atmosphere monitoring service. But there is some small delay before new data is available, so for the very recent images, the CAMS data might not be yet available. As an output from the service, the Sentoo-like creates .safe format products. So one option is to get zipped .safe folder structures as output, one for each product, and process them further with another tool that understands the .safe folder structure. The other option is to create a multiband geotiff of the common bands that the tool produces. In the .safe folder, there are the common bands and then separately the native bands for each case, for which there is no correspondence between Sentinel-2 and Landsat 8. The band naming is in the output follows the Sentinel-2 notation. So the Landsat 8 bands 5, 6, 7 will have names 8A, 11, and 12 in the Sentoo-like output geotiffs. And as said, these services have the pay-per-use mode, and hopefully we have it soon published on NOR. And the cost is one FTEP coin per processed image. So when you process multiple images or a long time period, the cost is dependent how many products are actually generated for the period. And then if we have a look at the platform, we have here a sample of the Send-to-like single image tool parameters. One thing to be noted is that we have a user manual. And from the user manual, we have links to this Send-to-like documentation. So you will find the links when you go to the FTEP service page. And from this documentation, you have a short description of the inputs and outputs of the tool. In this case, I took an area in southern France for this April. Cloud coverage 5% maximum, and the minimum image coverage 20% of the tile. So you can specify how large a proportion of the tile should be filled by the Landsat images. You can select whether or not to create the fused outputs. The harmonized output will be always generated. You can specify a reference image for geometry corrections. And if you don't need all the bands, you can define a subset of the bands. And then there's a very handy option when you look for data. You can check this to true, and in that case the Send-to-like doesn't process anything, it just checks what images would be available for processing, and that doesn't cost anything. So you can tune your parameters, and then when you have a nice subset of or nice set of images, then you can set it to do the actual processing. The atmospheric correction options, no corrections, SMAC or Send-to-core, output .safe or GeoTIFF. And for the GeoTIFF output, you can choose whether you would like to have an integer image with the scale 0 to 10,000 or a float image in the range of 0 to 1. And a choice of resolutions for the GeoTIFF files. And in this case, this job has processed 4 images, 2 versions per image. These are GeoTIFF versions, so we can use, for example, FTEP's QGIS service to see what has been in the output. This example is from this April from Arles in southern France. And we can here, the colors are not optimized, but the color scheme is the same for all images. So if we have first a Sentinel-2 image, another Sentinel-2 image, then we have the Landsat 8 image, which has been fused, and again a Sentinel-2 image. And then we can compare this. This is the harmonized Landsat 8 image, and this is then the fused version of the same image. So there's some distinguishable difference in the images. And the Send-to-like product service, here you also need to specify the tile identifier and the dates for the images. Currently, the service is not able to deduce the dates from the inputs. So these dates are needed for the auxiliary data download. You specify the products to process, then you can set the cloud and image coverage thresholds, whether or not to create a fused output, reference for geometry correction, bands, atmospheric correction as in the Send-to like single tile. And then there's this input image processing order field, which can be used if you have, for example, both Sentinel-2 and Landsat images and you want to be sure that the images are processed in the correct order. And then the same output options as in the Send-to like single tile. I think this was a quick overview of the two services that are now published and waiting to be used.
Thank you very much, Lauri. I could put on one summary slide before we head to the Q&A session. So here, and before the summary, I would maybe just mention that when Lauri introduced Send-to-like pay-per-use model, that one coin is used per image, I could clarify that these coin credits are acquired with euros, the European currency, but the actual pricing will be moderate, but it is not yet public. We need to finalize it at the time of publishing. So then we can inform you about the euros per coin relation. But otherwise, the summary is explained here, and for Send-to-like as well, we would like to offer all the webinar attendees a special opportunity to get the first access to Send-to-like. The guidance is there on the screen, so if you like to try it out, you can send email to us in the near days, and we will assign you credits for testing out the service before it is properly published. But now then the Q&A part, and I think we have at least 2 questions. And okay. Jukka, have you noticed them already?
Yes. Yes, thank you. Thank you everyone for the very nice presentations. Yes, I will take the questions. So the first one about the spectral recovery tool. So a person says, very nice tool anyway. How could you reach 100% for the whole polygon when parts of it were still blue, open, meaning in the output images?
Yeah, this is a good observation. Indeed, we have to remember that this we're talking about or comparing the averages, and as you remember, so in the graph you see the average graph, and it has reached 100% for the whole polygon. But if you remember the actual image, how the distribution was, there were those bluer areas that were below 100% or below 1 in that scale. But then there were many areas that were actually above that 100%. So in 120% or something compared to the original reference. So then the tool simply calculates the average of these pixel values within the polygon. So it may be actually even the average may be above 100%, although there are some areas that are still less. But this is why it's important to actually look at the spatial distribution, and because that may be the most valuable information that you can get, that there are certain areas that you have to focus on regarding the restoration or recovery, although the other areas are recovering well.
Okay, thank you, Rani. Sorry, Jukka. There's another question about spectral recovery tool. Is there any comparative assessments or methods available to convert spectral recovery to above ground biomass recovery? If AGB stands for that.
Yeah, okay. Yes, very interesting topic again. I mean, in theory, mostly this tool has been used to monitor return of tree cover, basically. But technically, what we are actually, or what the tool does, it monitors the development of the various indices. So if you are particularly interested in above ground biomass, you would need to find an index that in your interest area correlates very well with above ground biomass. This might be very well possible, especially in the early stages of development, but the user would need to, in that case, or in any case, actually understand very well the ecosystem that they are monitoring and what indices would best serve for what kind of recovery assessment. Then a bit more complicated way, of course, would be to develop your own index or find data sets and indices from those data sets that then would correlate very well to above ground biomass, and then this same framework basically could be used to implement that kind of analysis as well.
I might actually talking about customizing indices, and also there are several recovery metrics that you showed that are available and that offer different and distinct information about the recovery process. Can we modify actually these metrics by changing the variables that are involved in calculation?
In this current tool that is now implemented in Forestry TEP, the users cannot modify them.
Okay.
But of course, the source codes are all available for this tool. So if you are handy with Python, yes, you can definitely modify them to meet your needs. And then, of course, when that modification has been made, then that modified script could then be implemented in Forestry TEP as a service, so that the users of that could then use it the same way as this basic service is currently used.
Okay. One more question about Centralike. Have you tried diffing numerical interpretation already? If yes, what is your perception on it?
Unfortunately, I haven't used it for real applications yet. Visually they looked quite nice, but no numerical testing yet. So it remains to be seen.
Okay. Thanks, Larry. Maybe one last question, because these are, for example, the spectral recovery is an open source package, so it evolves. There will be potentially many releases. How does it work actually? If there is an update of the software package, how is it translated in the platform? Is there any?
Yeah, we try to, at least all like major updates, we try to incorporate them also in this service that is running in Forestry TEP.
Okay. Okay, thank you so much. I think we're running a bit out of time. Please, for all the attendees, if you have any further questions, feel free to send them to us and to the presenters. We can answer them offline. I will go through the NOR portal very quickly for the presentation of the sponsorship process. Can you see my screen?
Yes.
Okay, perfect. So here is actually I will put the link in the chat later for the NOR portal. So you have the landing page here in nordiscover.org. So you can scroll down for some information about the NOR, the initiative, the objectives, the onboarded providers, the approved projects, etc. Then you can go directly actually here on the top where you have the menu. So you have the homepage, you have, for example, the news section that you can click on where we publish the news related to the NOR initiative. So the trainings, the webinars, the onboarding of new services, the events, etc. If I go back here, you also have the outreach page, which we just put actually online. That's one of the things we display there are the webinars. So you have access to all the sessions and the recordings that redirect you to the YouTube where we upload the recordings of the sessions. And you have the portfolio, which lists all the services that are available on the NOR. So you can access it here. And here, for example, you can, if you know the service that you are looking for, you can search it here. You can do some filtering based on the areas, the service type, the source, etc. And if you know the service, you can just scroll. For example, here we're looking for Forestry tab. So you can access directly the website of the provider. You can have an idea about the collections that are available in the platform. You have the contacts for the provider help desk, the training offers, and the pricing wizards, which you have to go to where you have to go if you want to initiate the sponsorship process. So here you can indicate the type of the application that you want to develop. You have commercial, research, pre-commercial, and educational. And as a reminder, the network of resources only sponsors research, pre-commercial, and educational applications. For example, here, let's say research. Then here you have a listing of all the offerings that are available on Forestry tab. For example, we can use the data processing as a service for just 3 months. You also have the training offerings that you can choose. And at the end, you have an estimation of the cost. Here you have to indicate if it's an ESA project or no. So if it's an ESA project, you need to indicate the contract, the number of the contract, and it has to be signed by an ESA technical officer. So here, let's say that it's not an ESA project. And you have the option also to co-fund the costs of the resources. Let's say here that we do not co-fund. And here also you have the option to go directly to the provider website to purchase the resources or ask for the network of resources sponsorship. So here I will click on Ask ESA for sponsorship. And you are redirected to the sponsorship form where you have to, so here you put the project title, the name of the project coordinator, the word category, the email address, and we need an institutional email address, the organization, the country. So there's a set of basic information to fill in, for example, also the web page, the address, and here we ask you for a description of the project objectives and also the implementation methodology. So it's a small paragraph about the methodology that you want to implement for your application, the results that will be generated from your workflow, and also justification for the selected service provider. That's why actually we always advise you to get in touch with the provider to make sure that the services that you are requesting sponsorship for indeed answer your needs in terms of application developments, data, etc. And here also you have to put a small description of the work within the cloud environment, the area of interest for your project. If this is the first time you apply for a NOR sponsorship request, otherwise you will have to put the ID for the previous sponsorship request. Then you have to confirm that you fulfill all the commitments and the conditions. And at the end, you have a summary of the costs of the resources that you just asked for, and a summary of the whether you co-founded or not. And here we ask you for an expected date of submission of the set of slides. So it's a set of 5 PowerPoint presentation slides, just to give us a summary about the work that you performed in the cloud using the services that you received the sponsorship for. You can either sign up or not to the NOR newsletter, and you have to accept the conditions. And then you will be able to export the sponsorship request in a PDF format, and you will have to send it to this NOR sponsorship request address. And there will be a processing of your request, and you will receive a response, roughly speaking, 6 days after you submit your form. And that's all about the sponsorship request. If you have any questions, please send us via email. We will be happy to answer them offline. Thank you so much. I think we are running out of time. I see more questions coming in the chat. Maybe we can take this last one before closing the session. So we use Centralike in another project at VTT. Before it was implemented on Forestry TEP, harmonized time series analysis went well. Data was consistent. Oh, this is not a question. This is actually a link to the previous question about numerical interpretation of Centralike. Well, thank you, Mathieu, for the precision. Okay, thank you so much. Thanks, everyone, for the nice presentations. Thanks for the attendees. Again, feel free to reach out to us with your questions that we can answer offline. And at the end of the session, actually, there will be a form that will pop up. Please feel free to fill it in to help us enhance the training initiative. And we hope to see you very soon in another training session of the Network of Resources webinar series. Thank you, everyone.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.